Just 2 minutes. Setting the this one. Just 2 minutes. Almost over. side. One side lifted, one side up. So, every day same problem. Just taking it forward. Okay. Start. By further repair, it will become never ending. Some adjustment required in the camera. Same problem. Is voice fully clear? Voice is fully clear? Clear? Okay, let's start. Okay, now you start. See, I wrote the result there. Anybody, suppose, does not want to know the principle on what basis the buckling load for the column will come in strength of materials. See, practically, it may not be possible to satisfy the exact end conditions. So, some corrections are there. But theoretically, actually, fixed end is, hinged end is okay. Fixed end actually base, foundation base, you take fixed. It will not be absolutely fixed. Upper side, rigid joint will come. So, for all that one, corrections are applied by respective codes. So, in strength of materials, we consider standard cases. Case number 1, I'll put somewhere here. This is case number 1, case number 2, case number 3, case number 4. Everywhere length of column is L. Then both are hinged or pinned ends. Both are fixed ends. Base one end fixed, one end hinged or pinned. One end fixed, other end free. These are the buckling load. By seeing here, you can make out this is the strongest of all the columns. See, rank point of view, if you give rank, topmost rank, that is the maximum strength is this one, rank number 1, first rank. Why? This will buckle at very high load. See, if a column buckles at very high load, it is stronger. A column is weaker if it buckles at a lesser load. See, strongest of all. This is the second rank. This is the third rank. This is the fourth one, that is weakest of all. So, but anyway, usually when you derive, you go not in the rank order. First you take both pinned ends. Because that is the standard case for what? Euler's buckling load. Even later, all these three are converted to equivalent to this one. Okay, now, both end fixed, one fixed, one hinge, one fixed, one free. So start. Now, the solution solution for buckling load is obtained by using differential equations. I will tell you how to write it systematic way. I will tell later when the time comes. Okay, now, see, first, write heading here. I think board I should check up to where visible, up to where not visible. Later, I can't turn the camera. Anisha. Oh no, see, I have to come little this side. Up to where I have to come. Oh, this much is consumed. I think I should slightly turn the camera this side because lot of space is wasted there. Left side, right side, that much not required. I'll slightly shift it. Okay, suppose now visible I think. So, okay, manageable. I will write available space only. Fourth, the case number It's not visible now because of turning. These are all called minor adjustments. This only will spoil the classes. These minor adjustments. Technical problem is okay, but these problems are okay. Little edge comes there, nothing to worry. Okay, we will bother about that one. Right, left side you can see little edge. Okay, now up to where? Up to here. My hand, if I reduce further problem, where up to where? Wherever I go. Okay, here. Okay, I'll put a line here. No, not there, not visible. Little this side. I am losing space. See, these things all, I should not waste time. Okay, now came. Start. Now, heading, everywhere, main heading. See, remember, I will do systematically all the 4 cases, telling how the result came. First one, blue color I will write. See, Euler's 1, case number 1. Euler's buckling load for a column. If requirement is there, I will rub that one. Note down that one. You take a screenshot of this one. If requirement is there, I will rub, because why? I wrote the result earlier for those who are not interested in the derivation. Okay. So you can note down and rub it down. For a column with see, both ends fixed. Both, I put end condition, I'll use red color. With both ends fixed. Both ends fixed. Fixed. Okay, now some standard statement you have to write. I will tell one by one now. See, everywhere standard statement. Consider a column, consider a long column. See, both end not fixed actually, both end hinged. Where I am? Consider a long column hinged at both ends. Hinged at both ends. Both ends. See, both ends. Full stop. Okay, next. Let PB be buckling load. Let PB be buckling load. Right now PB, I'll put red color. PB is the buckling load. Now, further statement. Let L be length of the column. Length of column. Actual length. Remember, later this L is called actual length. See, this L is called actual length. Not effective length. Actual length. Remember. And also let EI be least. I told why least. Least flexural rigidity. Flexure rigidity of cross section of column. I am making pakka derivation so that systematic way. Okay, now do one thing. Correctly put the case here. See, both are pinned. This all, see, last time what all I told, you should remember. Everything I told last time you should remember. See, dotted line. Initially dotted line. Okay, now elastic curve. What will happen? This is the buckling load. See, this is the load at which the column will buckle, PB. If that is 1 minute, is the top visible? Tell me, is the top visible, or shall I lift slightly? Top visible? Okay. Top fully visible? Yet visible, I think. Top portion visible? Yes, okay. Now, elastic curve, I will put a blue color. The reason is there. See, this is the elastic curve. Dotted line is initial line. Now, see, this is direction. Now, I will take this point as A, this point as B. Length I will mark here. Length I will mark here. And now itself, I will put boundary condition. See, I told you there is theta. So, no problem. There is theta. If it is there, leave it. But here, deflection y at A equal to 0, deflection y at B equal to 0. Before that one, you take a section xx, see, xx at x from here. The statement you have to write. After the sketch, write. Next statement is, see, after all this, next statement I will put here now. Next statement will be, consider section xx at x from top A. I will take permanently from A, top. And also let, see, y suffix x, at present red color. Later I will not use red color. Y suffix x be what? Displacement or horizontal deflection, or I will put displacement, or I can call this is the linear displacement, or I can call deflection, anything. B linear displacement, okay, linear, remember, or B displacement, not angular. Displacement means linear at xx, over. Now you require very important bending moment at section xx. I will tell only once xx, that is called mx. Remember now, if it's a beam, you can take sagging positive, hogging negative. This is a column. You see, those who look from this side, they will tell sagging. Those who look from this side, they will tell, see, if the column buckles this way, those who are standing here, they will tell sagging. Those people will tell hogging. If you come here, people will tell hogging, they will tell, see, if the bending is this way, these from here, people will tell sagging, from there hogging. So here, it hardly matters because sign for bending are not important. One sign I require. See, what I will do is, if this is xx, see, xx, what bending moment you will do is, see, 1 minute I will tell you. I can take, look this way, see, this is the BM. If that is the BM there, this is the BM here. This I will take positive. That is, see, this way. You can take this way also. But if you take this way, one problem comes. When you go for solution, root of negative will come, I will come, but nothing to worry. It is going to be squared later. I square will become -1. Sign will, other sign will be change of sign will be there. Answer will come same. Therefore, that you remember. Or you can remember easy method. Look upper side. Actually not allowed. Not allowed. Still, look upper side. See, clockwise. Actually wrong. You should not tell clockwise. See, this type. That is clockwise, positive. If you look this side, anti-clockwise, negative. You always look that side. You always look that side. Therefore, see, this is positive. And one more important, right? Right now you are right. When you take bending moment here, it is not here. You write a note. When you find bending moment at the point, section xx, you should find bending moment for the column after buckling. Means you should find bending moment here. See, you write here, bending moment, see, here. Next time I won't write. Here bending moment. See, if I take bending moment here, it becomes 0. Or, remember, advanced study. Have you heard of P delta analysis? Have you heard of P delta analysis? Have you heard it? A term called P delta analysis in earthquake all. Heard it or not? P delta analysis. Have you heard it? P delta analysis. That is effect of displacement on this section forces. Yes, this is actually P delta. Remember, see, suppose there is a column. I will tell you why it is called P delta. Further I can't tell. Suppose there is a column here. See, if you apply a load, axial load, one fixed, one free. Here BM will become 0. Look this side. But when it deform this way, the load will shift here. Tell me. Now, for the same point here, bending moment will come or not? See, when you shift this way, because of the shifting, your load applied here is applied here. Since the load is shifted now, will it create bending moment or not? It will create BM of this load into this distance. Or this is the bending moment due to displacement. Usually you find bending moment what? Load into linear distances, 6 meter, 4 meter like that. No. This is the bending moment due to buckling or displacement. Clear? Clear or not? This is the bending moment due to displacement. This is what people call P delta analysis. At least you might have heard of it, P delta analysis. See, ideal example is analysis of column for buckling. This is called P delta analysis. Further I won't tell. Okay. So now onwards, when you find BM for the column, you should take bending moment here. Means at XX, after the displacement, where is the final point? There, not here. If you take here, BM becomes 0. See, here bending moment equal to PB into Y. It is PB is the load into YX. Tell me, as per this convention, it is this way, plus or minus. See, you look that side, this is positive. See, this is positive bending for us. This is positive. It is plus or minus. See here, our sign is positive. Now, it is this way, positive or negative. That's all I want. It is positive or negative. If you answer that one, over, negative, minus, minus. Okay, right. Now, immediately you write. See, I should not keep on telling same thing. This statement you write first. I am solving all the 4 cases today systematically. Today's class will go a little longer way, maybe up to 9:30. I told that FPM batch. So I will complete the column today because halfway through I can't leave. And first write the basic statement. Then EI is the least flexibility of the cross section. Put the boundary condition. These all I explained last class. Anybody who knew, suppose they ask you, sir, why 0? Go back to last class. I told take a screenshot. All the 4 cases, boundary conditions I wrote last time. We are going to use it now. Okay, then find BM here. Load into this distance minus. Next step, the moment you get bending moment, immediately what you do? Equate to, remember, EI d square y by dx square. Tell me, remember or not? The moment you get bending moment, equate to EI d square y by dx square. Those who want right, we know basic differential equation. EI d square y by dx square equal to mx. Remember it? That is the basic differential equation. Yes. Remember, I will tell you one thing. No indeterminate structure can be solved without using this condition. Okay, let me see. Some people will tell, sir, I can solve. How? Solve me. I use 3-moment theorem. Okay, derive it. Then he will tell, oh, no, sir. There also we use it. Okay, I will use moment distribution method. Okay, use it. Distribution factor. What is that one? Stiffness by etc. Stiffness, how you got? Sir, 4EI by L. How you got it? When you take, sir, we are using it. No method is existing for indeterminate structure because indeterminate structure effect of displacement is there without using this basic differential equation. EI d square y by dx square equal to mx. No indeterminate structure can be analyzed. Okay, over. Now next step is very important. See, you should write, rearrange it to differential equation form. How means, see, I will tell you here. Note, what you do is d square y by dx square and y term should come to LHS equal to, other should go to RHS permanently. I won't tell again and again. This is the way you have solved. D square y by dx square and y term should be LHS. Here all y means what? Y at any point x, remember. See, this d square y by dx square and y term should be left hand side. Anything else, even if y, d square y, if y is not there, should go to other side. Okay, now start. I had here. Therefore, see, I can write EI d square y by dx square. This I want to go other side. Y plus PB into y. Y means yx. Okay, I do one thing. Now onwards, if you write y, it means y at x. Clear? When you write some variable without suffix, it's waste of time. Okay, plus yx. Here also yx required. Plus yx equal to 0. Correct? Is it correct now? These always still not ready. See, one more thing. This you bring it. Then you want to d square y by dx square, nothing should be there. There should be no coefficient. What you do? Now, or, therefore, I will write here, divide by EI. You write here, divide by EI. What you get? You get d square y by dx square plus PB divided by EI into yx equal to 0 is the differential equation. Correct? Well, fast. Clear? D square y by dx square. See, remember, when you go to solution of the differential equation, d square y by dx square should not have coefficient. Okay, now standard. I will put in the red color. We know that, see, we know that, I know, nobody is knowing properly. For that matter, even I am also not knowing correctly how to derive it because forgotten. Who will worry? It is a mathematically established form. Such things, higher mathematics. I know the equation. If someone asks, you prove it. This is not mathematical class. See, we know that, see, for a differential equation, see, for a differential equation, what? D square y by dx square plus a k1 into yx equal to k2. If there's a differential equation in the form d square y by dx square plus some constant k1 into yx equal to k2, then standard solution, I'll write it, then see, I'll use blue color now. Then solution is y at any point x equal to, see, c1 cos of x root k1 plus c2 sin of x root k1 only. c1 cos of x into root k1, c2 instead of cos sin of x root k1 plus k2 by k1. This is the standard solution for a differential equation d square y by dx square plus k1 into yx equal to k2. c1, c2 are constants to be eliminated using boundary conditions. See, this I can't explain further. Standard, it is a mathematical one. Okay, now go for every problem you bring to this form. Start. Therefore, now come here. For our question, therefore, solution is, for our problem, see, our solution is yx equal to, see here, c1 cos of x times root k1. See here, root k1. What is k1 here? D square y by dx square plus pb by ei into yx 0 means your k1 is pb by ei, root k1. So x root pb by ei plus c2 sin of x root pb by ei. Lastly, k2 by k1, 0 is there, plus 0 is the solution for our case number 1 when both ends are pinned. Clear? This is solution when both ends are pinned. Fully clear? You tell yes, I will go to boundary conditions. Over, both end pinned is over within no time. See, now go for boundary conditions. Boundary conditions. I already told you boundary conditions. I will not explain further. See here. These YA0 and YB0 are boundary conditions. Start here. ya equal to 0. That means your y becomes 0 for your x is measured from here for x equal to 0. Okay, start. Substituting 0 equal to C1 into cos of 0. When 0 is there, cos 0 is 1. That I should not tell for somebody who is studying this important concept. If someone tells, sir, why 1 means, I will tell 4 results are there, by heart it and study yourself. Don't worry. When 0 is there, cos 0 is 1 plus C2 into sin 0 is 0. Okay, now this full is 0. Therefore, see, 0 equal to C1, that's all. Or your C1 equal to 0. Remember, C1 equal to 0. You should know one thing. Your y depends upon, y is a function of C1 and C2 both. When C1 is 0, see, when you put any value of x, there is y. So when C1 is 0, now for this question, for this example, since C1 is 0, tell me later which cannot be 0. Reason. Which cannot be 0 now. I will tell you later which cannot be 0. Once you got C1 0, which cannot be 0. C2 cannot be 0 because I will tell later. If C1 is 0, C2 is 0, then anywhere in the column, deflection becomes 0. Whatever load you apply, column will not buckle. Not possible. So later remember, since C1 is already 0, C2 cannot be 0. Okay, remember. Start. Now, therefore, after each boundary condition, what I will do is, I will substitute in the equation. Once again, see, therefore, your yx will now change over to C1 is 0. Only what? C2 sine of x root PB by EI. This is what? Reduced version of yx, C1 0. Okay, now, next boundary condition. Deflection at B equal to 0. See, yb 0. Therefore, y becomes 0 for x equal to, again y becomes 0 for x equal to L. Okay, start. Substituting 0 equal to C2 into sine of L root PB by EI. Okay, now, very important, 0. Therefore, see, therefore, either what? Either C2 equal to 0 or sine of L root PB by EI equal to 0. But remember, but just now I told, C2 cannot be 0. C2 cannot be 0 because already C1 is 0. Therefore, only chance is what? Therefore, you write here, only possibility is what? Sine of L root PB by EI equal to 0. Now, therefore, what? Sine of L root PB equal to, therefore, L root PB by EI equal to sine inverse 0. Tell the answer, sine inverse 0. Tell the first number. Sine inverse 0, first number. Sine of what is 0? First value. First. Sine inverse 0, first number. First number. First number, sine inverse 0, first number. For which value of trigonometric function, sine is 0, first number. This much time. Sine theta is 0 for theta equal to what? First value. If you delay this much, what I can do? If this much delay for answering sine inverse 0, how I can take the class? 0. 1 is 0. But remember, 0 you cannot take. Why? If you take 0, I will tell you, see, L cannot be 0. PB cannot be 0. 1 0. Go to next number. 0. Next number. Next number first. 0. Next number. See, 180 you cannot write. Remember, this is structural engineering. This is theta means dy by dx. So degree is not allowed in any, see, you cannot use degree in the trigonometric function when you use differential equation. Degree is ruled out. Answer should be in radian. Remember, answer should be in radian. So tell next number. 1 is 0. Okay, 180 is correct. 180 is how many radians? Pi. 0, pi, 2 pi, 3 pi, etc., etc. Correct? Pi 0, pi, 2 pi, 3 pi, etc., etc. Okay, now, right. 0 you cannot take. See, 0 is ruled out. Why? Because if you take 0, length can't be 0, buckling load becomes 0. Means there is a column, without applying load, column will buckle. No. I told you earlier. Therefore, see, I told you earlier, taking least positive value. For this one, take the least positive value. Tell the answer. Taking least, I told last time, when you analyze a column for buckling load is the least load at which column will buckle. So answer is what? Least positive value is pi. Therefore, you get L root PB by EI equal to pi. Now what you do is square both sides. Square it. See, I will put squaring. This also is not writing. Okay, I will change the pen. Squaring, what do you get? Squaring, you get L square into PB by EI equal to pi square. Okay, now this is over now. Therefore, for a column with both ends hinged, you get the answer buckling load PB equal to, what is the answer? Pi square EI equal to pi square EI by L square is the buckling load for a column with both ends pinned. See here, I wrote the answer. Pi square EI by L square is the least load at which column will buckle. Clear? Buckling load for a column with both ends pinned. Fully clear? Go through again and again and study. Furthermore, I can't explain because this class is permanently there. You can go through any number of times. If it is a Zoom class, it will be deleted later. But here, YouTube class. So, permanently it will be there. Any day if you want doubt, you can go through the class. Okay, start. Now, one case over. Start now. Second case. I'll start here. Case number 2. User's buckling load for a column not both ends not hinged now. Now I am changing both ends fixed. Okay, start. Statement. Consider a long column not hinged, fixed at both ends. Let PB be buckling load. Let L be length of column. EI is least as usual. Then put the sketch. But remember, sketch will change. I will put the sketch will keep on changing. I cannot maintain the same sketch because parameter will change. This sketch last time thoroughly explained for you. Before buckling and after buckling, thoroughly explained last time. See here how it will be. This is fixed. I will not explain because why? Last time so thoroughly explained. This way fixed. See now. Elastic curve will come. Red color. I will put blue color. Elastic curve. To understand, blue is better. Elastic curve. See. It will be zero slope here. This way and this way. See. This is elastic curve. Now this point is A. This point is B. Length is L. And then here the buckling load is PB. I told you last time PB means this also PB, and now I told there will be a reacting moment here. I told very clearly last time MA and a reacting moment here MB. Now we should take this all, first of all, I should not explain. Last time is the ending part. Did not I make fully clear? Tell me. The last time in the end of the part, I told screenshot. Didn't I make everything clear there? Everything. How to take the sketch. How is the reaction solved? Last time told or not? With slowly, full explain. Yes. So, therefore, go through it. Now if you take a section XX, at X from here, this is called your YX. This is your YX. Start. Consider section XX at X. Now, boundary condition. I'll put here. Boundary condition at A will be deflection at A equal to 0 and also slope at A equal to 0. And boundary condition at B is deflection at B equal to 0 and also slope at B equal to 0, or simple language. At the fixed end, slope and deflection both are 0. I told first time using deflection. Okay, start. Consider section XX at X from A. Let YX be displacement. Remember now bending moment here. See, here. How much answer? It is minus PB into YX plus, how much, tell me? Minus PB into YX, then plus, how much? Plus. What is that plus? Bending moment. Minus PB into YX, then plus how much? Plus one term will come now. Plus how much? Fast. Minus PB into YX plus MA. No into Y, it's a couple. Plus MA. No into Y, no into, it's a couple. Okay, start. Equal to EI d square Y by dx square. Okay, rearrange. Therefore, EI d square Y by dx square. See, this one you take other side. Y is there. MA will come right side. Equal to what? Here not 0, equal to MA. Now, divide throughout by EI. You get d square Y by dx square plus PB by YX equal to MA by EI. Okay, now do one thing. Now write the mathematical format. Now write mathematical format of the differential equation. Visible fully? Fully visible. Okay. Therefore, now solution is YX equal to, same C1 cos of X root. This is your K1, this is your K2. So, C1 cos X root PB by EI plus C2 sin X root PB by EI plus one term will come. Plus what? See there? Plus K plus what? Plus K2 by K1. K2 is MA by EI. K1 is PB by EI. K2 by K1 is MA by PB. Tell me, is it fully clear? Plus MA by PB. One extra term will come. This is clear? Fast. Plus MA by PB. When you solve K2 by K1, one more term will come. Fast. Clear or not? MA by PB will come. Last time 0 came. This time MA by PB. Okay, now start. Put boundary condition. Once again, see, start. This one. Deflection at A0. Y becomes 0 for X equal to 0. Start. 0 equal to C1 into cos 0 is 1 plus C2 into sin 0 is 0. Not over. Plus what? MA by PB. Therefore, now it will change. See, now equation will change. I can't use last one. Because why? Because now values are different. Okay. This I will remove now. Now, or what you get? Therefore, see, last time 0 came, C1 0. Therefore, your C1 equal to, take other side, minus MA by PB. Your C1 equal to, see, C1 equal to minus MA by PB. Therefore, do one thing. Therefore, now your YX will reduce to, now do one thing, substitute for C1. Go back and see, now you can eliminate C1, substitute here. Minus, see this equation, rewrite it. How to write? Minus MA by PB into cos of x root PB by EI plus C2 sin x root PB by EI plus MA by PB is the revised equation for Yx. Why? What happened is I removed C1, I substituted for C1. Okay, now this is over. Second condition here. Also at A, you know that theta A is 0. By this time you know it. You know that theta is always what? Dy by dx. So at A, theta A 0, that is, see, theta is always equal to what? Dy by dx. Therefore, what? Dy by dx equal to 0 for x equal to 0. See, actually, x equal to 0, theta 0. Theta is nothing but dy by dx. So, dy by dx equal to 0 for x equal to 0. Before you substitute, what you have to do? So, before substituting, first what? Differentiate and get dy by dx. Okay, right? Differentiating, you get dy by dx equal to, see, minus MA by PB, cos will become sine of x root PB by EI. Actually, when you differentiate cos, it becomes minus sine. So what you do? This minus will become plus. That much common sense. See, this minus is there. When you differentiate cos, it becomes what? Sine, minus sine. So then into what? Into root PB by EI plus C2 into sine becomes cos of x root PB by EI into root PB by EI. Lastly, when you differentiate here, both are constant. There is no x there. Both are 0. Okay, now this is the differentiation. Now substitute what? Dy by dx equal to 0 for x equal to 0. What do you get? See here, I will sit and write. 0 equal to, see, sine 0 is 0. Outrightly, see, sine 0 is 0 means you don't have to worry about this term. 0 plus C2 into cos of what? Cos 0 is 1. So directly into 1. Then into root PB by EI. Now, tell me. Therefore, what happens now? Either C2 equal to 0, see, either C2 0 or root of PB by EI equal to 0. But remember, PB by EI cannot be 0. Cannot be 0. Therefore, your C2 equal to 0. See, PB by EI cannot be 0. Then column will buckle with no load. Therefore, C2 0. Fully clear? Full clear or not? Therefore, you get C2 equal to 0. Okay. Now, therefore, I will come here now. Therefore, C2 becomes 0. Rewrite. Your Yx will now become, see, minus MA by PB into cos of x root PB by EI. C1, this over. C2 is 0. Skip this one. Plus MA by PB. This is the further reduced form of Yx. I removed what? C2 I removed. So this is remaining. Now, after A, now come to B. See, next boundary condition. Deflection at B equal to 0. Therefore, Y becomes 0 for X equal to L. Substituting 0 equal to minus MA by PB into cos of L root PB by EI plus MA by PB. 0. Now, MA by PB will cancel or it will become, take other side. You get cos of L root PB by EI equal to, usually when I take academic class, I will write 0 here and go further. People will tell, yes, sir. Finally, this answer will not come. Then I will start acting as if I am confused. What happened? I don't know what happened. Then somebody in the class will tell, sir, there is a wrong there. Equal to not 0, sir. Equal to what? Tell me. It is not equal to 0. It is equal to what? when you cut this one, this will go this side. Equal to what? It is not 0. Equal to what? People will agree. In the academic class, I will do it. Equal to 1. Equal to 1. Then I will tell, oh, thank you very much. You saved my life today. Otherwise, what happened is, I would have lost my credibility today. Thank you very much. I will never forget you in future. Sometime he knows it. Newcomers, okay, it's okay, sir. After tells, okay, I will remove a paper from the pocket and show it to him. See, I know that it is not 0, it is 1. Oh, sir, you are fooling us. Yes. How I can make a mistake like that? I am not that much weak. Okay, start. Therefore, your L root PB by EI equal to cos inverse 1. Anybody can tell what is cos inverse 1? First number. Cos inverse 1. First number. First. In radians. First number is 0. Cos inverse 0 is 1. Next. Cos inverse 1 I want. Next number. 0 is okay. Cos 0 is 1. Next number. What cos of what number is once again 1? Tell me fast. You tell in degrees. I will convert radians. You tell in degrees. I will convert radians. 180 is wrong. Cos 180 is minus 1. What is this? Yes or no? What is this? Cos 180 is minus 1. I want cos inverse 1. Once cos 0 is 1. If you want once again 1, you have to come one full round. How much? Cos 360. That is what? 2 pi. Next is not 3 pi. 4 pi, etc., etc., etc. Clear? Tell me. Not pi. Pi not possible because cos pi is minus 1. I want plus 1. 2 pi. Okay. Now write. 0 is not possible. Right. Taking least positive value, L root PB by EI equal to 2 pi, or squaring both sides, L square into PB by EI equal to 2 pi becomes 4 pi square. Therefore, when the column is fixed at both ends, the buckling load PB equal to, see, PB equal to, not last time you got pi square EI by L square, 4 pi square EI by L square is the answer when the column is fixed at both ends. Clear or not? Tell me fast. Clear or not? So answer is 4 pi square EI by L square. See, these derivations you understand going through. Once you understand, then forget it. Then you see only this result. You don't have to do what research on this one, but you should know how the boundary conditions affect. See, when the fixed end is there, when both are pinned end, easy to buckle. When you got a fixed end, difficult to buckle. Why? The fixed end will not allow rotation. So you require higher effort to buckle. See, common sense will do. See here. If both are pinned end, see, easy to buckle. If both are fixed end, see, difficult to buckle. Easiest to buckle is what? One fix, one free. See, this is the easiest to buckle. Last case. Okay, now come to case number 3. See, case number 3. User's buckling load for a column with what? I had changed the language now. With one end fixed and other hinged. Hinged or pinned, anything. Other hinged. Okay, start. Consider a long column fixed at one end and hinged at the other end. Hinged at other end. Right. Let PB be buckling load. Usual statement. Now the sketch will change. Be careful. The sketch will change. Why? Now you should what? How sketch will change? Top is hinge. Bottom is fixed. Top deflection is 0, but slope is there. Bottom, both are 0. So if you draw elastic curve now, see. This is the column. Elastic curve will go this way. This all, sorry, blue color. Okay. Why blue? Red will do. Okay, no, whatever. Where is the blue color? There is no rule that you should use blue color only. There is no such rules. But I maintain the same color throughout. Why change it? Just for one case. 1 minute. This is a usual problem. When I want it, not getting the blue color. Just now I was saying, oh, it's in the pocket only. Okay. See. Elastic curve will go, see, this way. Therefore, see, this is the point A, this is the point B. Remember, now boundary is deflection at A equal to 0 and theta is there. Here, deflection at B equal to 0 and slope at B equal to 0. Okay, now, as usual, this is the buckling load. See, this is the buckling load PB. When column will buckle, then there is a buckling load PB here. Then I told you, at the fixed support, a reacting moment MB will come. And then I told you last time, this will try to push it this side. So there is going to be a horizontal reaction, HA. If you forget this one, gone. See, forget this one, gone case. HA is there. Last time, and for balancing HA, there is HB here. As usual, length is L. And once again, take section XX at X from here. All clear now? This is your Y at X. Now bending moment here. Bending moment here now. These all I explained last time. Clear? See, why I explained because if I explain all this now during derivation, it becomes confusion. So every confusion I removed last time. By what? By telling you how are the reactions, how is the elastic curve, what are the boundary conditions last class. So today, fluently derive. Okay, start. Now, bending moment here equal to minus PB into Yx plus what? Plus your HA not over, see, HA into X, into X, into X. Okay, start. Equal to, see here, minus PB into Yx plus HA into X equal to EI d square Y by dx square. Okay, rearrange it. Now, rearranging, what you get? EI d square Y by dx square plus PB into Yx equal to what? Equal to HA into X. I told you, d square Y by dx square and what? Y should come to left hand side, other right hand side, or divide by EI. You get d square Y by dx square plus PB by EI into Yx equal to what? Equal to HA into X divided by EI is the differential equation. Now write standard form. Now this will become your C1, this will become your C2. So solution is Yx equal to same thing, C1 cos X root PB by EI plus C2 sin X root PBI plus C2 by C1. When you write C2 by C1, EI will cancel, HAX by PB will come. It will come what? HA into X by PB will come. Clear? See, K2 by K1. Tell me clear, I'll go to next step. Clear, okay, start. Now, boundary conditions. See, start. Y at A equal to 0. Y becomes 0 for X equal to 0. Start. Okay. Start here. 0 equal to C1 into cos 0 is 1 plus C2 into 0 plus, see, HA into X. You are putting X equal to 0. That also becomes 0. Why? X is 0. this is 0, this is 1. Therefore, C1, what do you get? 0 equal to C1, or your C1 will become 0. Therefore, rewriting your yx will now become, C1 is gone. C2 sine of x root PB by EI plus HA into x by PB is the answer. This is the equation for what? Revised equation for yx. C1 already gone. Now C2 will come. Okay, now 1 minute. Very hot today. Now be very careful. Derivation of the Euler's buckling load for case number 1, case number 2, both end fixed. Then what? I can remove this one. Okay, remove this one. For both end fixed and what? For both end hinged, starting to are easier. And last case also easier. Derivation of the Euler's buckling load for one end fixed, one end hinge has got complications. It has got complications. Some trigonometric complications are there. Nothing to worry. I will take care of that one. So now you should be little careful. Okay, or now I have to remove this one. I want more space. Remember now, this answer I got. This also we got. Now you are getting this answer. Remember, you will get 2 pi square EI by L square. I will remove everything. Next case, we will get pi square EI by 4L square, advance booking. Hey, you are go. You both are go now. Why? Because space problem is there. Okay, start. Now, okay, at A, y is 0. No more conditions. Now come to B. When you come to B, what happens? Tell me. When you come to B, next, y at B equal to 0. Therefore, your y becomes 0 for x equal to L. Start. 0 equal to C2 into sine of L root PB by EI plus what? Plus HA by PB. Correct? Plus HA by PB. Correct now? 0 equal to C2 sine of x root, x root, L root PB by EI plus HA into PB, or your C2 will become minus, take other side, minus HA by PB divided by sine of L root PB by EI. Or now I can tell, therefore your revised equation is yx equal to, see here, C2, what is C2? Minus HA by PB into sine of L root PB by EI, that is C2. C2 is over now. Then C2 over into sine of, be careful, not there in this equation. Here x is x only, into sine of x root PB by EI plus what? HA into x plus HA into x divided by what? Divided by PB. Now this is the revised equation for yx. Clear now? In case something is wrong, I will correct it. First tell me, this step is clear? You have tell clear this step. Into L, where into L? Where into L? You told into L. Where? So one thing, something wrong means you can't solve the question. One number gone means you can't solve it. Where into L? HA 0 equal to C2 sine L root PB by I plus HA by PB into L. Oh, see there. One small mistake means what will happen? Gone case. You can't solve the question. Okay. So this is what? HA into L. Oh, thank you. See, this is really thanks. This is not, I forgot that one. See, I forgot to use the L. Thank you very much. Who told? Such things you should observe. Yes. No, these things, if you should observe it, really thankful. Because why? Otherwise, later, answer would not have come. If answer is not coming, what I will do? I won't get panic. I will tell, see, if I remember, last time I derived this column buckling load, maybe, I don't know first of all, maybe 10 years earlier, 10 also not 10 years, much earlier. I don't remember when I had done it, column. Today I came to the class happily without seeing here and there. Why? I know answer has to come. If the mathematical format is correct, if the equations are correct, end conditions are correct, then answer has to come. I never get panic. I came without bothering. Whether I can, sometimes people will practice, but I'll advise those who are going to teaching line, don't do that way. Dangerous. You get stuck somewhere means, if I get stuck somewhere, I can tell something wrong in substitution. Principle is not wrong. But you cannot tell that way. So be careful. Those who go to teaching line, you should be careful. I advise you to study thoroughly and go. See, till you get the complete grip. Okay, start. Thank you very much. Who told? Suresh told, I think. L. Okay, now, this is over. This is over. Now, last condition. What? Theta b equal to 0. That is, dy by dx equal to 0 for x equal to L. So, before substituting, differentiate. Tell the answer. Dy by dx equal to, what is the answer? This is constant, minus HAL by PB into sine of L root PB by EI into sine will become cos of L root PB by EI plus what? When you differentiate this one, what it will become? HA by PB into X will become HA by PB. X will become 1. Clear? X will become 1 when you differentiate. That also important. Clear now? Clear? That X will become 1. Fast tell me. If clear, I will go to the next step. I am asking why clear just to confirm. Okay, now substitute dy by dx equal to 0 for x equal to L. See here. 0 equal to minus HAL by PB into sine of L root PB by EI plus what? Plus HA by PB, into what? Into cos of L root PB by EI plus HA by PB, or this will give you 0 equal to, see, minus, see, or you can do one thing, see, or you can write 0 equal to minus HAL by PB, HAL by PB into cos L root PB by EI by sin L root PB by EI is what? Tell me. Sin by cos by sin is what? Cos by sin is what? What is cos by sin? What is cos by sin? Into root, what is missing? What is missing? Tell me. Which is missing? Where missing? Missing means problem. Into root of missing, sir. Where? Into root of PB by EI. Where? Where missing? Into root of PB by EI. Where missing? Where missing? No. Where missing? First of all, tell me where missing. Dy by dx equation. I'll check once again. See. Oh, see. Oh, when you take dy by dx, it becomes, see, sometimes. minus HAL by PB sin L root P by I into cos, see now, see, into what? Or see, into root PB by EI. Thank you very much. Then plus what? HA by PB. Now correct? Okay. Sometimes it happens. But anyway, you can make out now. Now correct? See, when you differentiate, sine of x root PB by EI becomes cos of what? When you here, when you here also I have right. See, when you differentiate HAL by PBI into cos of sine, because actually here not L, what should write? See, when you differentiate dy by dx equal to constant HAL by PB sine L root PBI plus cos of x only here, x root PBI into root PBI plus HABB. Now substitute dy by dx equal to 0 for x equal to L. Now correct? Tell me. Sometimes numbers are missing here and there. Now correct? Correct. Okay. Start. Or 0 equal to what? Minus HAL by PB into what? See, cos of L root PB by EI divided by sine of L root PB by EI into what? Into root PB by EI, then plus HA by PB. Correct now? Correct or not? Into HA by PB. Now correct? Minus HAL by PB into cos L root PB by I by sine L root PB by I into root PB by I plus HA by PB. Correct. Okay. Now see, HA by PB cancels, or if you take other side, what happens now? 0 equal to what? 0 equal to what do you get? Minus of cos by sine is cot. Cot of L root PB by EI plus 1. PBI not over. Into what? Root PB by EI plus 1. Or what you can do? Tell me. Or take this side. What do you get now? Equal to 1. Or cot of L root PB by EI into root PB by EI equal to 1. Correct? Cot of root PB by EI into root PB by EI equal to 1. Correct? Check fast. Anything wrong, answer will not come. Or I'll do one thing. I do not want cot. I want take that side. Tell the answer. Or root PB by EI equal to 1. L is missing, I think. Where is that L? Some L is missing. Root PB by EI equal to what? No. Cot becomes tan of, see, take this way, that side, tan of L root PB by EI. No. One L is missing. Where L missing? Yes, see. L is there. See. There is a L here. Now see. Cot of L root PB by EI into root, actually L is there. L. Okay. L into what? L into, this here also I forgot that L. Here L is there here. See. So L, what you can write? Minus, see, take the other side. Cot L into, or you can do one thing. Better way is what? Take other side. Or cot of L root PB by EI into L root PB by EI equal to 1. Or I do not want cot. I want tan. Take other side. So you can write what? L root PB by EI equal to tan of L root PB by EI. Or interchange. You can tell tan of L root PB by EI equal to L root PB by EI. Fully clear? This is the complication of this case. Fully clear? You get tan of L root PB by EI equal to L root PB by EI. Full correct now? Okay, now do one thing. You are right. This is of the form a special mathematics what? Tan theta equal to theta. Correct? This is a special function of tan theta equal to theta, where theta equal to L root PB by EI. See? Yes or no? This is of the form tan theta equal to theta. When you take tan, you should get back the same answer. Tan of something equal to same answer. Clear? Okay. Now, remember, for tan theta equal to theta, remember, now go to mathematics. For tan theta equal to theta, your theta equal to 1 is 0. Tell me, what is tan 0? Fast. What is tan 0? Fast, tell me. What is tan 0? Take your calculator. Tan 0. Tan 0 is 0. Tan 0 is how much? 1 is it. See, tan 0 equal to 0. So, if tan 0, but you can't take 0. Next number is a unique number. Remember, the next number is a unique number. I will tell you what is that number. See, 1 minute. I know that number. So, if you go once for 0, actually for 0 radians, tan 0 equal to 0. Remember, activate radian button. First, activate radian. Clear or not? First, activate radian. Clear? Tell me first. First, activate radian. Done it? Radian should be displayed. Tell fast. First, activate radian. Over. First, activate radian. Okay. Now, next, I know the answer. Actually, long back in this room, somewhere there, I wrote that number for 10 decimals. I struggled for more than 3-4 hours. I got that secret number. But later, during painting, that number gone. That was long back. During painting, that number gone. Then I forgot it. Anyway, remember, next number is, see, I will tell you how to get it. Anyway, you remember number. See, radian should be active. Such a button so that when you take tan, same number should come. See, tan, you believe me now, tan 1 is 1.5557. No, that is not the answer. I know it. Actually, it keeps on increasing. Tan 2 radians is negative. Tan 3 radian is minus 0.14. Tan 4 radians is, I am getting nearby. See, tan 4 equal to 1.157. Next, tan 4.4 is tan 4.4 is 3. Coming nearby, not 96. Tan 4.49 is tan 4.49 is nearby 4.42225. 4.49 tan 4.49. Anybody can tell number? Actually, people will tell. So I want accurate answer. Anybody can tell what is that number for which tan theta will come theta? Tell the number. Take your calculator. That way, slowly go further. I want accurate answer. 4.49. One particular number, it will give same answer. Tell the number. Those who are in the BSK batch should tell the number. Tan how much? Tan of what number will once again give same number? This much difficulty. 4.49. 342. How so fast you got? Yaru? Nodi. Suresh SN got within no time. You tell me a secret after the class. Call me and tell me how you got so fast. Okay. Tan 4.49342. If I operate calculator, tan 4.49342 is 4.49. Tan 4.49342 is 4. Not 342, I think. tan 4.49 341. 341. 341 is 4.49 342. Yo. See, point not one difference. Clear now? You take your calculator in radian mode. In radian mode, press tan 4.49341. It will come once again tan 4.49342. Got it? In the calculator, got it? In the calculator, got it or not? Tell me. You take your calculator and see, is the number coming or not? Because I know that number. See, earlier I got this number up to 10 decimals. 4.493098654 like that. Just for fun. Got it? Okay. Or people, what you will do is, you can people throughout world, people round up to how much? 4.5. Clear? Throughout the world, people round it up to 4.5. Agreed? To simplify, they will tell, or 4.49. Okay. 4.49. Okay, you do one thing. You take 4.4934. Uh, 4.493. Okay, 4.493. Agreed? But usually what people will tell is, why you are struggling? You by heart it. It's almost equal to 4.5. Right? Tan theta 0. For this, theta equal to approximately equal to 4.493, or people usually tell approximately 4.5. Clear? Throughout the world, any textbook you see, they will write approximately equal to 4.5. But we will write 4.493. Over. Therefore, remember, tan of L root PB by EI equal to L root PBI. Therefore, I will write here now. Little space required. See, I need little space. I will remove this one now. I will remove this one. Therefore, what you can tell? Therefore, L root PB by EI equal to 4.493. Square both sides. Squaring, you get L square equal to L square into PB by EI equal to 4.493 square, or your buckling load PB equal to what? 4.493 square into EI by L square. Correct? 4.493 square into EI by L square. Correct? Correct or not? Correct. But usually we want in terms of pi. So what you do? Or equal to 4.493 square divided by pi square into pi square EI by L square. Why? Because people always want in the form of pi square EI by L square. Now tell me, what is number? Take pi square outside, or equal to, tell the number, 4.493 square by pi square number. What is the number? Because people always want in terms of pi square. Everybody wants in terms of pi square. So take out pi square. Answer. 4.493, 2.0453. 2.0453 pi square EI by L square. Or you can tell, when the column is fixed at one end, hinge other end, the buckling load PB is almost equal to, tell the answer, round up the number, instead of 2.0453, people round up to how much? Standard. See, first pi square EI by L square is exact answer. Second, 4 pi square EI by L square, exact answer. Next coming up, pi square EI by 4L square is exact. Only one of them is approximate. Tell the answer. Universally, people take how much? Universally, nobody takes 2.045. What they take? This number, nobody takes 2.045. They take what? 2 pi square EI by L square. This is the buckling load for the column when one end is fixed other is hinged. Fully clear? Tell fast. Fully clear means now last case. Then special discussion is there. I first thought today I will finish all the cases, go for discussion. Now I think discussion will take 1 hour. The importance of the buckling load, the slenderness ratio, all behavior, then slenderness ratio, everything is there. Comparing user's load with the short column, what wrong result you get, then Rankine's formula, that all you have discussed. Therefore, no, leave it now. But all clear? Now, last case pending. That is what? Column with one end fixed and other end what? Column with one end fixed and other end. One fixed end, other end. One end fixed, other end. For that answer is pi square EI divided by 4L square. What other case? One end fixed, other end free. I will do one thing now. I will finish today only. Why? Next time if I keep all this I can't write. So today only I will finish. But I talk non-stop without any breathing time for 1.5 hours nearly. It is, you speak this way for 1 hour, you will realize how much strain comes. So I talk non-stop and see, these are all mathematical, more voice, lot of writing. If it is a numerical problem, I enjoy. This is not that way. Here I should be very, very careful. In spite of that one number skipped, see, trouble came. But I was not worried. Why? This number has to come means has to come in my class. Okay. So I will take some 5-6 minutes break. Okay, don't leave the class. Because I will complete the 4 and today, at the end of the class, in the full board, I will write the answer and convert to effective length today only. Because why? Next time I will be native place. Little small board there. So next time, tomorrow I am going to native place. Tomorrow I told no class there. I am going by evening train. So Friday class will be there. There I will discuss all the important significance. So today only I want 4 cases answer and also replace to L effective. Okay. Just 5-6 minutes break for me. You just meanwhile study something. Don't waste time. Don't leave the class. 5-6 minutes break you take. I will also take. Meanwhile, you see here. Don't waste the time. Or you do one thing. Take a paper and try one fix, one free. See whether you are getting or not. Try. Try. I am not going there to practice that one. I am going to take a small break. That's all. Okay. Just 5-6 minutes. start. Because I have to, in a little time, I will finish all the basic cases because today I will put the final result for all the cases and bring it to common term. Which one? Pi square EI by L effective square. Discussion will be next class, Friday. Friday class is the most important class, remember. Because Friday, you are going to learn the real concept about all the column in RCC or steel, where in case of columns, where you get effective length and slenderness ratio, long column, short column, that all discussion will be on Friday. So Friday there will be lot of principles are there. Very, very important. I want to tell again and again. All those who came today, without forgetting, come Friday also. Okay, now, last case. I want is red color now, black only. Fourth one. User's buckling load for a column with one end fixed and other end free. Consider a long column fixed at one end and, free at the other end. Let PB be buckling load. Now sketch will change. Now you should be very, very careful about the sketch. I told you. See, in all the previous cases, what happened is, the buckling load point was there only. But the applied load point, the PB where you apply, will remain same. Now see, initially, column is like this. Column is like this. Now, buckling, blue color required. Okay. Blue color. Where is the blue color? Buckling also, as usual, blue color, so that uniformity is maintained. Got it. See, now elastic curve will go like this. See, here, condition. The deflection is 0 here, deflection at B0, slope at B0. And this is the point A. This is the point A. This is the point B. See now, buckling load is applied here. It will not be there. If you apply buckling load there, when the point moves, your load will travel to a new position. Clear? This point load, see, that's why I told you P delta analysis. The bending moment here, see, earlier load is here, but now load also moved. So now length is L as usual. Length is L. And now if I take a section XX, have patience for at least 5-10 minutes more. That's all. If I take a section XX now, when I want red color, I won't get it. Usual. Only black. Otherwise, red will start coming like anything. Okay. Now, if I take a section XX here, at X from here, this is your deflection YX. And very important, XX here, your BM point is here. Notice, when you write BM, you are right here. This is L. And this point will deflect by, I don't know how much, that displacement is Y at A. So at A, deflection is YA. It is not 0. Clear? At A, deflection is not 0. It is YA. Clear or not? Deflection is not 0. It is deflection at A. This clarity required. This I told you last time. This is called what? See, you can understand P delta analysis. Because of the load shifting here, it will cause bending moment now. Okay, start. Bending moment at XX, Mx equal to bending moment here equal to PB into, see now, it will change now. It is PB into, see, bending moment here, PB into this distance, that is YA minus YX. It is YA minus YX. Now it is plus, see. Earlier it was this side minus, now it is plus. Here see, reaction moments are there, not required for us. This step is clear. This step is clear means over. Then very simple. You tell me this step is clear. Okay, done. Now equal to what? EI d square y by dx square. Okay, rearrange. Rearranging EI, see here, or I can remove this one now. Or you can write what? EI d square y by dx square equal to what? PB into YA minus PB into YX. Or rearrange it, EI d square y by dx square plus PB into YX equal to what? PB into YA. Divide throughout by EI. D square y by dx square plus PB by EI YX equal to what? Equal to, see, PB YA by what is 1? Equal to what? Divided by what? EI. Equal to PB YA by EI. PB into YA by EI. This fully clear? This step is clear? Fast tell me, because I want clarity. Take other side. PD is equal to PB by EI YX equal to PB YA by EI. Okay. Now, divide throughout by EI. What do you get? This equation. Now, this is your K1, this is your K2. Now, same story write once again. Differential equation. Therefore, your solution is what? For this differential equation, solution is your YX equal to C1 cos of X root PB by EI plus C2 sin X root PB by EI, same story, plus K2 by K1. Nodi. This is PB by EI YX into YA. What do you get? K2 by K1. When you do K2 by K1, PB YA by EI divided by PB by EI is YA. Correct now? See, K2 by K1, YA, sufficient. Okay, now start boundary conditions. Boundary condition. Now remember, I want to eliminate this YA. How to eliminate here? See, Y equal to YA for at A, Y equal to YA, or at A, Y is not at A, Y is not 0, Y equal to YA. Therefore, your Y becomes YA for X equal to 0. Start. 0 equal to C1 into cos 0 is 1 plus sin 0 is 0 plus YA. Therefore, your C1 equal to what? Your C1 equal to what? C1 equal to minus YA. Fully clear? Your C1 equal to minus YA. This is also clear? Fast tell me. Okay, start. Or rewriting it. Rewriting, what do you get? Your YX will now becomes C1 minus YA into cos of X root PB by EI plus C2 sin of X root PB by EI plus YA is the new equation for YX. Okay, start. Now further. This boundary over. Come here. Next is deflection at B equal to 0. That is, Y becomes 0 for X equal to L. Y becomes 0 for X equal to L. Start. 0 equal to minus YA into cos of L root PB by EI plus C2 sin of L root PB by EI plus YA. Plus YA. Oh, there is something wrong. Unish here. Oh, see, suddenly I got the shock of my life. I got the shock of my life. Okay. What clear? Ayyo, what is this? See, I suddenly, because of the strain, forgot. When X equal to 0, Y becomes YA. What nonsense is this? What you are doing? You are not concentrating. See, at A, Y equal to YA or Y equal to YA for X equal to 0. Therefore, Y is not 0. YA equal to C1 into cos 0. Cos 0 is 1 plus this is 0 plus YA. What is this? See, when X equal to 0, Y is not 0. Y equal to YA. If you are also not doing, got the mistake now? Tell me, Is it clear or not now? What blunder is made? Not actually blunder only it is. I got the shock because when I saw the next equation, I was wondering how the solution will go down to differential format. I was wondering how it can turn out differential format. Okay. See, how I came to know? Because when I wrote next equation, I looked at the equation. Then I thought, if this is the equation, how to bring it to differential form, that is trigonometric form. Suddenly I realized, see, no panic, or YA cancels, therefore your C1 equal to 0 or 1 minute. See, when Yx is this equation, when x equal to 0, then Yx equal to Ya means C1 should be 0. Therefore, your Yx will rewriting the equation, Yx is what? C2 sine of L root PB by EI plus Ya. Yes or no? Correct or not? Equation, tell me. See, one small mistake means you will never get the answer. But I will not be under panic. I will not be under panic. Why should I get panic? Only chance is what? Substitution mistake, or that I call print mistake in my class. Technical mistake will not be there. Okay, start. Now, at A over, come to B. When you come to B, deflection at B equal to 0. Therefore, Y becomes 0 for X equal to L. Substitute. 0 equal to C2 sine L root PB by EI plus Ya, or your C2 will become minus Ya divided by sine of L root PB by EI. Correct? Your C2 will become minus Ya divided by, correct answer, C2 equal to minus Ya by sine L root PB, or your new format equation is rewriting it. Your Yx equal to, see, C2 minus Ya divided by sine of L root PB by EI, then that is C2 into sine of, oh sorry, this is X actually, see, you are not observing, this is X. When you substitute, Ya becomes what? C1 0 means Yx is in terms of X only. Now correct. Into sine of X root PB by EI, then plus what? Plus Ya is new format of Yx. Now, last condition. What is last condition? At the point B, theta B equal to 0. Therefore, what? Before using theta B is what? Dy by dx. Before using this one, first differentiate. So your dy by dx equal to minus Ya divided by sine of L root PB by EI into what? Sine becomes cos of L root PB by EI. This will become 0. Why? Oh, sorry, this is x root PB by EI into root PB by EI plus 0. This is also clear. When you differentiate, dy by dx equal to this a constant minus Ya by sine L root PB by EI into sine becomes cos x root PB by EI into root PB by EI plus 0. Tell me, if this is clear, over. Okay, now start. Now substitute dy by dx equal to 0, that is theta equal to 0, for x equal to L. What do you get? 0 equal to minus Ya by sine of L root PB by EI into cos of L root PB by EI plus 0. Tell me now. Therefore, see here, Ya cannot be 0. Tell why. Ya cannot be 0. Tell why reason. Simple reason. Why Ya cannot be 0? Bottom fixed, top free. When buckling takes place, top point has to move. Tell yes or no. Deflection at A cannot be 0. Why? Because when the top is free, when the column buckles, top has to move. You tell yes or no. Top has to move. So Ya cannot be 0. And next, your sine of L root PB by EI can also be not 0. Tell why? Because it is in denominator. Because if it is 0, what will happen? Answer. Tell me. If the denominator is 0, what will happen? If the denominator is 0, what will happen? It will become what? If denominator is 0, what will happen? It can't be 0. When something equal to 0, denominator cannot be 0. Why? Reason. If denominator is 0, it will become what? Answer. Infinity. So therefore, only chance is cos of L root PB by EI equal to 0. Therefore, L root PB by EI equal to cos inverse 0. Tell me cos inverse 0. Cos 0 is not 0. First cos 0 when? Tell me. First cos 0 for what value? First cos 0 for what value? Cos inverse 0 means 0 is not the answer. Why? Cos 0 is 1. Tell me 90 degrees. 90 you should not write. Pi by 2, comma 3 pi by 2, comma 5 pi by 2, etc. Therefore, taking least value, L root PB by EI equal to pi by 2, or squaring both sides, L square PB by EI equal to pi square by 4, or Euler's buckling load PB for a column with one end fixed, other end P is what? Equal to, see, pi square EI divided by 4L square. Is it fully clear? Tell me. If fully clear, I will go to summary now. Today only summary. Another 5 minutes more. Today only summary, so that I will tell you next time take screenshot. Those who come to next class, they should have screenshot ready with me. Next time I will tell you have the screenshot with you, attend the class. Otherwise, you are as good as not my student. Okay. Now, all over what I promised, how much answer I told should come, every answer came. See, I told you without any tension. I was not at all tensed or what. If this was see, before the class, I was not worried. They suddenly starting buckling load, trigonometric functions are there. Will I get the answer or not? I know d square y by dx square plus k1 into y equal to k2. Solution is y equal to, it is a complementary function, first particular integral. C1 cos x root k1 plus C2 sin x root k2, x root k1 plus k2 by k1. I know it. Then anything remaining is structural knowledge. Fortunately, I am confident of structural knowledge. So without worry, I came to the class. See, that is called confidence. Not I am telling I am boosting or like that. Confidence counts. So, okay, now see, final result. See, I will write here, both ends pinned, both ends hinged. You can write either hinged or pinned. Next, both ends fixed. Don't put case number. Both ends fixed. Next one end fixed and other pinned, other hinged. Actually, next time what I will do is, before the class, I will write in the board this one so that I can explain. Lastly, one end fixed and other end free. See here. Everywhere common, final. L stands for actual length. Clear? L stands for actual length. Clear or not? In all the formula, L stands for actual length. Okay. Now, see here. column with both pinned. I will put blue color. Both pinned. Column with both fixed. Blue color. I won't show PB now. Column with one pin and other fixed. Column with one free and other fixed. Elastic curve. Elastic curve. Elastic curve. Elastic curve. Buckling load PB. PB here. Buckling load PB. PB. Of course, some moments are going to come here. Let it come. Here, buckling load PB, anti-clockwise moment and buckling load PB, horizontal reaction is there. Okay, here, buckling load PB is here, not there. Load will shift here, PB, and here, reaction and moment. Okay, over. Now, everywhere, length is L. Here also, actual length is L. Actual length is L. Actual length is L. I use red color. What I got is, I got buckling load PB equal to, this color is faded now, it is a new color, new red color, PB equal to pi square EI by L square. I got PB equal to 4 pi square, correct, 4 pi square EI by L square, 1 fix 1 inch. I got PB equal to 2 times pi square EI by L square. I got buckling load equal to, not I got, is standard, pi square EI by 4L square. These are the buckling loads based on actual length. Now see, if you see the next time, I will tell you first rank. This is first rank, strongest column. This is second rank. This is third rank. This is the weakest column, fourth rank. Now what I will do is, I will rewrite this equation, or see, I can write this as pi square EI equal to pi square EI equal to pi square EI equal to pi square EI by some denominator square, by some denominator square, by some denominator square, which is a function of L. Tell the answer here. What? Tell me answer. Pi square EI by what? First, this you should tell. Some function here. How much here? Number, value. Only compare my, tell me. This principle I will explain Friday class. Divide by L, tell only L. Square I made, you tell only value. Square already over, you don't type square. L here. Pi square EI by 4 will come to denominator. L square by 4, answer. L square by 4, answer. L by 2. Here, L by. Next one, L by root 2. Here, 2L. Now also, this is first rank only. Why? Denominator is reducing means buckling load increases. This all I will tell next time. Or, now see, next time this proof I will not give. Or, I will do one thing now. See, I write here. Or, let, see here, common for all. Let, for any end condition, you call buckling load PB equal to pi square EI by L effective square. One common number. For all the cases, you write only one thing. Pi square EI by L effective square. Okay. Now, board is not visible. I have to slightly lift the board. Okay. I should write L effective now. Over, last part. I should slightly lift the board. Top is not visible. No problem. Top will not be visible. Top will not be visible. Or I will make the screen little smaller. Okay, that is better. Instead of struggling that way, I will make the screen little smaller. Okay. ಒಂದು ನಿಮಿಷ. Yes. It has become too much small. Okay. Now visible fully. Concluding part. Now, if I write something here, is it visible? If I write something there, is it visible? Fast. Okay. See now. Therefore, when both are pendant, L, if the length is L, L effective is also equal to L. When both are fixed end, if length is L, L effective equal to L by 2. If one end is pin, other is fixed. If length is L, L effective equal to L by root 2. See here. Whereas if one end is fixed, other is free. If length is L, L effective equal to 2 times L. Is full board visible what I wrote now? All the 4 fully visible for you? Or shall I turn the camera? What I wrote just now, is it fully visible or shall I rotate the camera slightly? Shall I slightly rotate the camera? Or visible? Okay, I lift it. Okay, now see. Okay, now, okay, full, I can lift much more. These all I will tell you next time. See, if both are pendant, L effective equal to L. Effective length equal to actual length. If both are fixed end, effective length equal to actual length by 2. Good or bad? Tell me. RCC or steel? Good or bad? If L effective is reduced, good or bad? RCC all. Good or bad? If the effective length becomes lesser, strength point of view, good or bad? Good. If one is fixed, one is pinned, L effective equal to L by root 2. Some people write it as what? Some people write what? 0.707 L. Some people write this as what? 0.5 L. Clear? Sometime 0.5 L. But practically IS code told, even though theoretically 0.5, recommended is not 0.5. They want to take slightly more length for safety. That all I will tell you in the next class. Next class I will tell you. Now, this portion what I wrote here, Friday class in the board, little smaller board in native place, I will write neatly, not this way. So screenshot is not required. But take a screenshot. But you study the screenshot, very important. Study the class only. Friday class, I will tell all practical concept here. Effective length means what? What actually means effective length? What is slenderness ratio? Then that buckling, why EI is least. With all those things, I will explain on Friday class. Clear? Friday class will be what? Pure technical and complete concept for column. Then next week, 1 or 2 classes, I will do some numericals. Sufficient. I won't waste time like academic questions. Some important numerical I will solve. Of course, I will tell about Rankine's formula also. I should tell drawback of Euler's formula, limitations of Euler's formula, and then tell Rankine's formula. Then same Rankine's formula, IS code modified, earlier as straight line formula, then some secant formula. Now even the new IS code, that is what? Still, there also format is same. See, in the IS code C steel, you get FCC. FCC is pi square E by lambda square. Lambda is that what? L effective by R. That all I will tell tomorrow. Okay. Now 9:40, beyond the limit. All the concept clear. See, derivation, do not waste too much time. Understand the principle on what basis answer came. Then forget it. Forget means what? Keep the derivation, write in a format. Once in a while go through it. Do not waste time. I want to master the derivation. That you do only if you are going for teaching line. Otherwise, concept should be completely clear. Okay. As usual I told, tomorrow I will be traveling by night train. Train leaves by 9 o'clock. I have to leave the classroom by around 7 o'clock. Tomorrow no. Friday class is there. Coming week also, one day I am coming back by self-driving. I don't know when it is. I will inform you later. Most probably Thursday, coming Thursday, I'm returning back to Bangalore. I will inform you in the group. Those who are in the BSK group, I will inform you. Others, when they get the notification, they attend the classes. Okay. Concept, this much shouting for more than 2 hours. Really useful, at least. See, principles are still pending. The basic or delicate principles are still pending. But concept is clear. How buckling load came. Concept clear means, okay. Thank you for wishing happy journey. Thank you. Okay, we'll meet on coming Friday. Okay, thank you.